I used to have to spray glyphosate back when I worked as a field hand. We would walk through the entire field spraying, even though there was only weeds in small patches. It was nasty work, and at the time I always wished there was a better way. Well, since then, robotics, computer vision, and access to cheap hardware has gotten way better. And so now I'm gonna do what I can to see if I can build a system to help mitigate that problem. So I've got $400 in parts here, and we're gonna see if we can make this work. So for some context on why this is so important, modern agriculture is hugely reliant upon chemical herbicides for weed control. And that can have big negative ramifications, not only for consumers, but also for workers. Bayer, the maker of Roundup, has paid out over $10 billion in lawsuit claims. And organizations like the IARC have said that glyphosate, which is the key ingredient, is probably a human carcinogen. So anything we can do to limit this pesticide use is a net benefit for everyone. Not only that, but there actually are organic pesticides on the market, but they can be anywhere from 5 to 100 times or more expensive than traditional chemicals. And so they're just not financially feasible unless you can apply them in hyper-precise targeted ways. So if we can actually build a system to only apply chemicals right on the weeds, we could actually use far less toxic chemicals and make them affordable. This is not a new idea. Companies like John Deere already have large tractor-pulled systems that use computer vision to only spray in targeted areas. There's also startups like Robotics, and they have an ultra-precise computer vision spraying system, and they claim they can reduce pesticide use by up to 95%. Meanwhile, there's startups like Carbon Robotics, and they've taken an approach where they use computer vision to guide lasers that actually burn the weeds. So the question isn't if weed control matters, the question is, who is it for? All of the systems I mentioned are big systems that cost hundreds of thousands, potentially up to $1 million, and they don't work in all cases. They don't fit in small fields or greenhouses. They don't work for certain crops, including some berries, vegetables, and ginseng. And they certainly don't work if a farmer can't afford them. And so that's the gap in the market I'd love to be able to help address. So to be clear, this is not the final version by any means. This is just the smallest, simplest, ugliest prototype that I could think of to test if this is even gonna be able to work. The final version that I'd hope to be able to build is a fully autonomous robotic precision spraying system that can go through fields and only target weeds and spray them. But this first version is way simpler, where I just want to see if I can use computer vision to reliably detect weeds and then only spray on that spot when the sprayer is right over them. So let's go over how I plan to build this thing. Starting with it, we've got our backpack sprayer. Obviously, that's what's going to spray it. It is battery operated, and one of the benefits there is it'll be able to keep a constant pressure. I don't want too much variation with the spray pattern, or that's going to make everything harder. So step one. The next step will be, where am I going to mount everything? And I've got this one-wheeled, it's actually a distance measure device. So farmers would use this to measure off their fields, but what's nice is that it's a really rugged rig. It's all metal, and it made it really easy for me to mount this initial sprayer here. So I've just got some hose clamps and some rubber matting. Then I've got my 12-volt battery. This is what's going to be used to power my solenoid valve. And what I'll do is I'll put this solenoid valve in line with the sprayer. And then another benefit of this spray system is this valve right here. I just have that locked closed or locked open so that it's going to constantly spray, but I can unlock it and close it so that even if my solenoid valve and my computer system goes crazy, I'm just not spraying everywhere. So once I've got that basic plumbing hooked up, the electronics are going to be the solenoid valve is attached to this USB relay, and that's what's going to be able to plug into my laptop with these USB extension cables alongside the webcam. And that'll be in this backpack. It's a little laptop backpack that I've got attached to the sprayer, so that'll be on my back. Eventually, I want to use an NVIDIA Jetson computer, but I needed to keep this cheap, And what's nice is if I have my laptop, I've got the screen right there, so I can open it up, look at the data. I don't have to transfer everything or connect to a new device. It's all right there. So another component to keep it easy in the beginning is this mini game controller. So before I've got the system working with computer vision, I want to be able to manually trigger sprays, and that way I can check the end-to-end latency through the system and gather that training data. Plus, it's got some other buttons, for example, starting and stopping video recording so that I'm not collecting too much data and filling up my hard drive, but I can only record when I'm actually going with the device. So that's what I'm trying to do to keep this all pretty simple. Of course, you got some other odds and ends like this diode. One of the things that's important when working with solenoid valves is because they're inductive systems, when you shut off that relay, there's a big spike in voltage back through the system. And if you don't have a diode in line to short that out, then it can actually go back through your relay and fry that. So that's really all the components. It's relatively straightforward, and I don't need too much extra electronics because I'm able to rely on my laptop and just that USB relay for this initial MVP. Another thing I want to be clear about is there's no chemicals used in this at all. So I need to keep this safe so that I can talk to farmers and demo it in their fields, and I don't want any residual chemicals of any kind in this. The only thing will be this non-toxic dye, but in the beginning I'll probably just use water to keep it from ruining the carpet in this room if there's ever little leaks. AI is freaking amazing because already in the first 10 minutes I've got a Python script working which allows me to turn on that relay. I just gave it the model for the remote, the model for the relay, looked up all the docs and got it figured out. So when I hold down the A key, you can see that light turn on and you can hear that little click, which is the switch closing. All right, I just finished wiring the circuit, so I just want to explain how this works. We've got the positive lead from the battery going through the relay, and this is in the normally open configuration, which means the circuit is off unless I actually power the relay with the remote. That positive lead is going to come out here, and through this three-way connector, it'll connect to this lead of the solenoid valve, which will then connect to the negative side here. But there's that diode I mentioned before, and what that's going to do is just a protective mechanism for the circuit. Because this is a solenoid and that has the inductive load, when it shuts off, current is actually going to flow the opposite way through the system. And I don't want that voltage spike to go through the relay because it could damage it. So this diode only allows current to go in one way. So when the current reverses, when it's shut off, it's going to short out across that diode and not go back through the relay. But when it's operating normally, that diode only lets current flow in one way, so the circuit just flows from the positive lead to the negative. Let's try it out. When I hit this A button, you can hear that solenoid valve opening. I just finished screwing in these hose barbs to my solenoid valve. I used some Teflon tape. That should create a nice tight seal to avoid any leaks. The next step is going to be fitting this whole thing and figuring out the lengths I need, because I'm going to be splicing this into the tube here, and I can only cut it once. I don't have any extra pipe, so I kind of got to get it right the first time. I got the plumbing all set up here, but I can already tell this is going to be a problem because this hose is too short. And also, I'm definitely going to have to be able to disconnect the backpack from the actual wheeled sprayer rig. And taking off that hose barb every time is going to be way too much of a pain. So I just ordered some quick connect barbs and a little extra hosing so I can make this plumbing work. Check out this gnarly cable management. I got that taped on there just so I can rough out the approximate lengths I'm going to need to hook this up to the backpack before cleaning that up a little bit. But I realize I'm also going to need some wire connectors so I can disconnect the electronics too. Shout out Bezos, got that ordered on Amazon with 1-day shipping. The next step, we're going to fill this up with some water and see if this leaks all over my carpet or not. I haven't tested this at all yet, so you're going to be able to see it first. Let's see if this works. Oh, heck yeah. All right, well, maybe we need to get a little bit more stable, but it's spraying, and I don't think it's leaking anywhere. Giving you a close-up here. You can see how that works. There is a little bit of latency in the system when I open and close it, which is kind of expected because there's just so much hose length in between the valve and where the actual sprayer is. Future versions, I'll definitely put the valve way closer to the actual spray head. That should make it way more responsive. All right, we got the webcam mounted right there. You can see what that looks like on the screen with the sprayer nozzle. And I've got the tools on the floor so you can see about how big the field of view is. One thing I had to do is attach the cable with a zip tie right there. This hinge is kind of loose, but since I've got that cable there, this should hold it tight. So even though I'm bouncing around in the field, it should stay in place. That about wraps up everything I can do today. So next steps will be waiting for that 1-day shipping, get the cabling all finished up, make it a little bit prettier, and then attach the quick connect and get it out in the field. There she is, super rough as promised, but you can see I got the cables cleaned up a little bit. Not very pretty, but for an MVP and to collect some data in the field, this should work. Let's get this hooked up for the first real test. Slide my laptop into the backpack here, and I've got this USB extension cable I can plug in. We'll turn on the pump. Now this whole thing will go on my back. This is where we've got the quick connect that I got on Amazon. Slide that on, and you can see the water going through the hose. So first we'll just give it a pulse, get some of the air out of the lines. So it looks like we found our first leak, which is not great because it's right by the electronics. I'm still not quite sure what's leaking, if it's the hose barb or the actual solenoid valve, but we got to get this fixed or it's going to cause some major problems. This is what happens when software engineers try plumbing.
20 minutes later.
So I think we got the leak fixed. I'm all sweaty, but let's give this another go. I should have all the air out of the lines now. I think one of the reasons I was having latency problems before was just because there wasn't enough pressure in the line. So when I'd open the solenoid valve, it would take a little bit for the liquid to actually come out. So you can see I got the fan nozzle now, which isn't super targeted, but I might switch it to something a little bit more pinpoint next. But you can see kind of how it sprays every time I click that button. So you can imagine how this would work in the field where you're going along. Every time it sees a patch of weeds, it's going to spray. But then the majority of the field usually doesn't have direct weeds there, so you don't have to. Overall, I'm pretty happy with how this build turned out. Obviously, it's nothing fancy, but it should be good enough to take out into the field and start collecting some data with that webcam and that manual sprayer. So I expect the hard part here is not as much on the computer vision side, but more on getting the computer vision to synchronize with the sprayer itself. So that's going to be something I'm especially focused on. The next step for me is going to be starting some conversations with farmers and getting permission to use this in their fields to collect that data, then work on the computer vision system. After that, if all goes well, I'm going to start ordering parts for building the actual robot itself. If this project is interesting to you, please give it a like or a follow. Also, I'm trying to make this an actual startup and I'm looking for potential co-founders or investors. So if that's you or anyone you know, please share that with them. The best way to get in touch with me is @koofdev on Telegram, or you can email me at morgankufal@gmail.com.